In the previous video, we have seen how to construct a graph using LangGraph. In this video, we will take it a little further. First, we will see how to get a single conversation from an agent, and then we will move on to having multi-turn conversations, and we call it as a chatbot, in which we will also add memory. To create a simple QA bot, we need to have the messages as the state. Here again, we have to first define the schema of this state. Here we have inherited typed dict. We can also add base model. Then we have written the agent as return message. Its only work is to return the message as it is. To build a graph, we have to first create an object for state graph by passing the state. We add the agent as a node. We create an edge from start to the agent and from the agent to the end. We compile the graph. It is possible to use invoke because the GraphPath message implements a runnable interface. The state has to have the key and the type because it is typed it, and we say that we are going to have a list of messages because we are going to convert it into a multi-turn conversation. First, we get the API key. Then we will have to create the object for the model. I have used a GPT-4o mini because that's the least expensive. We create the agent as a function. Here the agent is chatbot, and we have to pass a state and return the state. This LLM now is invoked on the message that is passed, and we expect the chatbot to return a response to the message that is passed. Let's create a conversational agent from this. Now I will have multiple messages that are added to the chatbot. So other than the key and the value, I need to say how the list is going to be managed, for which I make use of a function called the reducer function. There are reducer functions available already in LangGraph, and if we say add messages on the list, automatically the messages are added to the end of the list, even when we have a multi-turn conversation. The reducer function is what determines how the schema is to be updated. Now that we have this, let's update the memory. To update the memory, to add the memory, we have to import memory saver from langgraph.checkpoint.memory, create a object for it, and then we have to pass the thread ID as an argument in config, and when we pass it as if we want to create a conversational chatbot, we need to remember the previous conversation, for which we have to add the memory. To add memory, we have to import memory saver from langgraph.checkpoint.memory and create an object for it. The config, which has the thread ID, has to be passed when we invoke the LLM. For this, we have to have a config in which we have to have a JSON where the key is configurable, and we have to pass a thread ID. And this memory is available only in this thread. This conversation is ensured that is not available in thread ID 2, 3, etc. After that, this config is passed as one of the parameters in invoke. So first we create a question answering chatbot, and when we run it, let's say I say hi, the message is hi, and it is just returned by the agent. But if we want LLM to give its response, I will pip install langchain underscore OpenAI, and then I'm using the secrets key from Colab, and so I use from google.colab import user data, where I have imported my OpenAI API key. I have written my chatbot. I've created my graph. Now let's see how this works. If I give Python here, it gives me a response which says, sure, what would you like to know or do with Python, etc. If I want only the message from the reply, I have to print it using messages response of messages dot content. So I am saying probably oops, and if I give an enter, no problem, how can I assist you? Now this can be made into a continuous thing till I press quit, exit or Q. So for that, let me first say Python, and it gives me a response. Now let me say oops. What I'm expecting is I wanted to say about oops in Python. It says no problem, how can I assist you? But it does not seem to understand that I'm talking about Python. If you see the series of conversations, it has no idea about the previous conversations. And that is the reason we add memory. Now that we have added the message, remember I need a reducer function also, which is add messages. Now let me add the reducer function, and let me build a graph and use the memory. And now again let me do the same thing. So I say Python, and now when I say oops, it knows that I'm interested in oops in Python. Similarly, when I say inheritance, it also is able to figure out that it is the inheritance in